All right, today we're going to be looking at 10.1, language of hypothesis testing. Um, the objectives, we're going to determine the null and alternative hypothesis, 2, explain type 1 and type 2 errors, and 3, state conclusions to the hypothesis test. So this is a really good reading. It kind of sets up the idea of hypothesis testing. So in this example, it's saying you and your friends are making a wager. If you flip a coin and it comes up tails, your friend wins. If it comes up heads, you win. And your friend gets 5 tails in a row, and we want to know, are they cheating? So in order to do that, we find the probability that that happens. We determine if it's unusual, which in this case is saying is 3%. In our case, that's unusual. That means if we did this 100 times, 3 of those times would result in 5 in a row. So based on that evidence, we either need to decide, is he lucky that this just happened and this is one of those cases, or is he actually cheating and the probability of this coin landing on tails is not actually 50%. So that's how we get into setting up testing of a hypothesis. It gives you a little bit of the background, where it comes from, definition of a hypothesis test, how it starts, procedure based on sample evidence and the probability, and we use that with the characteristics of a population. So here are the steps. We're going to make a statement regarding the nature of a population. We're going to collect evidence, sample data to test, and then we're going to analyze it. So you got 2 big things to decide on, the null and alternative. So the null is denoted by this H with a little 0 called H naught. This is the null. This is the one to be tested. This is the one that is of no change or no effect, no difference, meaning that it's pretty close to the same. There's not much difference. The alternative is a statement that we're trying to find evidence to support. And here are some setups. So you could have a two-tailed, either they're equal or they're not equal, and notice they're telling you that the null is the one that's always going to be equal. So either they're equal or they're not equal, which meaning it's bigger or smaller. We're not really concerned either they're equal or not. We have a left-tailed test, which is testing that the alternative, this is read H1. Some books will have a little a down there, HA and HO, but ours has a 1. Left tail test, the alternative is saying that it's less than, and the null is just saying that they're equal. Now some books might say greater than or equal, just the opposite, but equal means no change, roughly the same. It could be a little bit greater, but if it's not significantly less, then they're roughly equal. And then a right-tailed test is just the opposite of the left. We're testing to see if it's greater than some value. Otherwise, it could be said that they're equal. It might be a little bit less, but we're really saying, is it greater than or not? It gives you a little bit of background on forming the hypothesis, which is some good reading. And then we get into types of error. So when we form hypothesis, we have 4 things. We can reject the null when the alternative is true. This would be a correct decision. We could not reject the null when the null is true, which means we're in favor of the null. That would be a correct decision. Type 1 error, when we reject the null when it is true. So we reject the null when the null is true. This is type 1. And then type 2, we do not reject the null when the alternative is true. So a little bit more on that, because I know that wording can be quite confusing. Here's a little table, a 2x2, showing you exactly what we just read. And then it kind of goes into like a court system. So for example, we are trying to describe these types of error with a court system. So we don't really say a defendant is guilty. We don't say they're innocent. We say either they're guilty or they're not guilty. We assume innocence, and then we're trying to prove beyond a reasonable doubt that they are guilty. or we don't have enough evidence, and so we say that they are not guilty. We do not say innocent. So if you go through this reading, it kind of explains that the type 1 error would be convicting someone who is innocent. So we're trying to prove their guilt. We fail to prove, and we say we fail to, or we have evidence and we say that this person is guilty when they should be considered innocent. So we reject this when it's true, when they're actually innocent. This would be type 1, so that would be like convicting an innocent person. Type 2 would be letting a guilty person go free. So a person is guilty, but we fail to reject the null, and so we reject the null when it is true is type 1. We fail to reject the null when the alternative is true is type 2. So that's what it explains. Again, that wording is kind of tricky when you're looking at it. I guess it was on this page. So again, reject the null when it is true is type 1. So that would be like convicting an innocent person. And then type 2 would be do not reject the null. So we fail to reject the null when the alternative is true. So it explains that in the reading. It's pretty good reading as far as what we are used to in the court of law. And so when we get down to type 1 and type 2 error, what's the chance that this would happen? So the alpha, Greek letter, that's the probability that we get type 1 error. So that's the chance that we reject the null when the null is true. So we reject the fact that they're innocent, saying that they're guilty when they are in fact innocent. That will be convicting an innocent person. Beta is a probability that we can have type 2 error, and that would be rejecting HO or not rejecting HO. So we're assuming innocence, and we are saying that this person is not guilty when in fact they are guilty. So we are letting a guilty man go free, and so this is how you figure out the probability of those two errors. Level of significance, alpha, that's the probability of type 1. And so when you go through here and read this, we try to make alpha really, really small. We want the chance of convicting an innocent person to be really, really small. Okay. Consequently, that means that it's possible, because we set the standard so high, so it's so small that we would convict an innocent person, that it's very likely that some guilty people go free, because we would rather let a guilty person go rather than lock up someone who is innocent. And so these two have an inverse relationship, and this good reading goes over how do you state the conclusion of hypothesis test. So that's some good reading there. And once we go through all of this, we will go over to MyMathLab and actually start doing some examples.